Okay, the hitch peg and the link peg will also allow us to build one part and use parametric equations in order to get one part for the price of two, basically, if you write it with equations. And this is something that's a slightly more advanced feature of Inventor, but really not that tough. Okay, so what we're going to do here, we're going to build the hitch peg, and we see this would be the outline that we're going to revolve. But we're going to first define a user parameter, okay, of d, which is the diameter. You could name that any variable you want. I'm going to name it d for diameter, and that's a 1/4 inch. So then to revolve it, the 0.125 is d divided by 2. The 1/2 inch diameter is d times 2. And then if you take d1 times 1.3, you get 0.65. So the only part of that drawing that is not a ratio with the diameter is the spherical radius of 0.208. Okay, and why are we doing this way? Because if we look at the hitch peg, all the equations are the same, except that your 1/4 inch diameter for your D1 is, that 1/4 inch height there is D times 4. Okay, so it's actually very simple. Okay, so let's go to Inventor. Let's start a sketch. We could just go on the front plane. Okay, and with my line tool, I'm just going to kind of zoom in a little bit here. I'm just going to eyeball that shape. Okay, and I know the hitch peg is about 0.65 long. I'm not going to put any numbers in. So I click to draw one line. And then what I want to do is click and drag to draw an arc. Okay, so that will give me my spherical radius. Let's make sure I get a horizontal line, and make sure, again, I'm paying attention to all those dotted lines, because I want that to be perpendicular to the origin then. So there's my full drawing. Oh, and look, I got a little tag there, so that would cause a problem. I better go trim that off. Okay, so now let's look at what we want to do. So we did a basic drawing first. Okay, haven't done any dimensions yet. I'm going to go to my f of x table, and I want to add a user parameter. Okay, so I clicked add numeric. I'm going to call it d, and it's a length in inches, so that's fine. And my parameter is 0.25 inches. So now that variable is stored. So then when I come in and do my dimensions, and I'm just going to follow them in order, this needs to be a radius, so it's going to be d divided by 2. Okay, and you notice things start to change. And then this height here is d times 2. And then this height here is this dimension, which was d1 times 3. Times 1.3. Okay, so when you do that, you see this f of x showing up. One more dimension of 0.208. And it's not fully constrained, so I must be missing some perpendicular constraints or something. So let's go in up. Let's see, it says one dimension needed. Oh, it's not constrained to the origin. So somehow that missed getting constrained to the origin. There we go. So now let's revolve around that axis. And there's the hitch peg. One more small detail is with all the pegs, we're supposed to put a 10 thousandths chamfer on the end of the peg that helps ease it to go into the hole. So technically, let me save this as Hitch Peg CJC. Okay, so there's the hitch peg. So now, to get the link peg, I'm going to do save as, change the name, call it link peg. Okay, now nothing has changed yet other than I changed the name. Now I can go back to my f of x table, my parameters table, and I can go back and change that original diameter to 0.0625, 16th of an inch. Okay, and you see everything changes. It got really small, other than the 0.208 dimension, which is supposed to be 0.1564, I think. What is that? 0.1562. Okay, and then the other thing that's supposed to change is that distance is supposed to be times 4. So it's actually a little bit longer peg. So I make those simple changes, save it, and now I have the link peg. So we get 2 parts for the price of 1.